So the future value is equal to some present value or beginning balance times parentheses 1 plus an APR divided by the number of periods per year, that's K, raised to the power N times K. And K is the number of compounding periods per year, and N is the number of years. So we went over that a little bit last time. So one way you could use this is you could try to find the future value of some investment. So let's say we invest $500 invested at, let's say 3% compounded quarterly, oops, for 10 years. So we want to deposit $500, 3%. We don't get it monthly, we get it quarterly, and it's going to happen for 10 years. So let's just plug in what we know. We want to try and find the future value, so that just gets to stay F. We do know the present value, that's what we're plugging in, that's the 500. So we got F equals, oops, 1,000. Where did I get that from? 500 times 1 plus 3%. On a computer, you can type 3% and get away with it. On most calculators, you can't. You'd have to convert that to a decimal, which would be 0.03. If I'm compounding quarterly, how many times a year do I get interest? 4 times a year. Yeah, so we divide by 4. And then the power, if I'm using a computer or a calculator, often we have to use that little caret button. And sometimes we need parentheses for the exponent. And so I would then type 10 times 4. Now 10 times 4 everyone can do in their head, so you could just type 40 and that would work too. So whip out your calculator, see what you get. I'm going to whip out my spreadsheet, see what I get. And I'm going to do the calculation in 2 different ways just to confirm it. So spreadsheet for finance. Let's start a new one. So finance practice, call it day 2. All right, so I've got problem number 1. I have what? Present value of 500. I have an APR of 3%. What else do I need to know? 10 years. And so I want to calculate the future value, so I'll put that in the last column here. And I think it's equal to the 500, so it's on the sheet, I just type it, times parentheses. Oh, I need the compounding periods. All right, I was forgetting something. Insert a column. 4 periods per year. All right, so one more time, 500 times parentheses 1 plus my APR over the compounding periods, raised to the power parentheses, periods times years, and hopefully you're all getting $670 something. I got 674.17. Which one? What I said. Okay, so we want to double check our calculations. So you're in the ballpark. So let me see what you typed there. Does it show it? 500 times 0.03. So let's see. Can I up arrow to that? Go over. Divided. Oh, you forgot to divide by 4 inside there. Yeah. So you that part right there. Yeah, and that should fix it. Okay. So that looks like it worked out okay. Let's blow this up so it's a little more readable. Highlight, that is my answer. There's my highlighter. Let's do green. So on the cheat sheet, I mentioned another way to do this. I think it's right here. That you can also use the future value function on the computer. So I'm going to try and do the future value function, see if it gives me the same amount. Future value function, I would type equals, it says FV, and Google recognizes, yeah, you want to do future value of some investment, okay? It says, what's your rate? So I come over here and I click on my rate. Now the trick about the rate is all of these functions in the spreadsheet don't want the APR, they want the periodic rate. How do I change the APR to the periodic rate? I divide by 4, so I'm gonna, since 4 is already on the screen, I can just hit divide and click on where the 4 is, comma, number of periods, that's like our exponent. So then I can just click on the periods times the years, comma, how much am I paying each month? No, nothing. Yeah, this isn't one of those where I'm paying monthly, so I enter 0. So that's the trick there. And if you look at that cheat sheet I gave you, for this kind of problem, it says the third thing you enter is a 0, because we're not making payments, okay? And then it says, what's the present value? So I type my 0, comma, and the key is, since we're putting this in the bank, it's coming out of our pocket, it's a negative amount to the computer. So I have to say negative present value, close parentheses, hit enter, and I should get the same number. Okay. So slightly different way to do it. With this problem up here, I have to worry about parentheses and order of operations. Down here, I just have to properly interpret what it means by rate, number of periods, payment amount, present value. And the more I do it, the more I get used to interpreting what those mean. Okay, so either way, it takes practice. Questions on this one? Okay, let's do another one. All right, so that's regular compound interest. Let's label this compound interest. Let's do a different one. We also got to a savings annuity the other day. So let's take a look at the savings annuity formula. Magic pen. And a savings annuity is where you make, for example, monthly payments into an account. And you want to know what the future value is after so many payments. And the way the book lists the formula is they call the future value P with a capital N next to it. And that means what's the value after N years is what that means. And to get that, what we do is they call D the payment that we make each month. And then we multiply that by a couple of sets of parentheses. 1 plus the rate over the compounding periods. So the inner part looks just like compound interest, and this is, it's repeated compound interest to the power nk minus 1 after we do that, close the second set of parentheses, right? So I just closed that one. And then I have to divide all of that by parentheses the periodic rate, which is R over K. So that is our formula using the order of operations and the given information. Now, some things you have to note. You have to be given an annual percentage rate and how often you are making the payments. Okay, you could do monthly payments, quarterly payments, could be whatever you want. Okay? The period that you pay has to be the same as the compounding period for the money. Otherwise, it gets way crazier, and that formula is out of control. The spreadsheet version of this formula is also future value. And it wants to know what is the periodic rate, that would be R over K. How many payments are you going to make altogether? That would be N times K. What is your monthly payment? And in this case, we're starting off with nothing in the bank, so the next number is a 0. And so that's the spreadsheet version of the formula. Just kind of curious. How many people prefer the top version of the formula compared to the spreadsheet version of the formula? Raise your hand. Wow, okay. Half the class prefers the top formula versus the spreadsheet. Cool, just curious. Yeah. Yeah, so more practice we get, the better it is. And I hope to give you more practice. All right, so let's apply this. So a situation that we might apply this to is maybe we're setting up a, I don't know, we want to buy a car in a few years, let's say, and we can afford to invest $50 each month. We're going to stash that away in savings. And let's do it at 4% over 10 years. We want to know what's the future value of this. And so we have two ways to do it. So I'll write the first one down on the board here, and then I'll type them into my spreadsheet. So here we would call it P after 10 years, P sub 10. And it would be equal to our payment, $50, times parentheses, parentheses. Gotta double up that first set. 1 plus 0.04. And how do I tweak the 4% to make it a monthly rate? Just divide by 12. Divide by 12. Close that. I'm going to run out of room here. Raise it to the power n times k. Subtract 1 from that. And then I have to divide that by, so I'm just going to put a, I guess I'll have to write it like this. Divide that by, I'm going to put it in parentheses. Oh, why did I write nk like that? Actually wanted to type what n and k were. Let's fix that. N is 10, k is 12, my exponent. And in the bottom, I'm going to have 0.04 over 12. And the denominator has to be in parentheses, otherwise the order of operations gets screwed up. It does it in the wrong order. Okay. So I'm going to try typing that in and doing the spreadsheet version. So whip out your calculator, see if you can type that and get a number. And hopefully we will agree on the number. Drag my spreadsheet over here so you can see that. And your exponent might need to be in parentheses, so be careful about that. All right, I'm getting 7,000-ish. Anybody else get that? Okay, so let me confirm it with another formula. $7,360.49. That sound like a winning number? All right, so here is my spreadsheet version. Let's bring that in here. All right, blow that up a little more. So it color codes it for me, which is kind of nice. My balance is off to the left. You can't quite see that. But it says take my, sorry, not my balance, my payment is the B6, that's off to the left there, times parentheses, parentheses, be careful with parentheses, 1 plus the rate, C6, divided by the periods per year, D6, raised to the power, parentheses, D6 times E6, so my periods times my years, minus 1, close parentheses, divided by the denominator in parentheses. So we have to be super, super careful with parentheses to make this work. And we got to get good at using our calculator, whether that calculator is a handheld, a phone, a spreadsheet, whatever it is. Questions on that version of the formula? Okay.
I have a question.
Yep. What's up?
I don't.
What's your question, Fen?
Oh, I thought the other classroom is asking. My question is, I don't quite understand why we divide the in the formula. Why we divide the rate, monthly rate?
Why we divide by the monthly rate here?
Right.
Okay, so I didn't go over that in detail, but that is in the book. So if you want, so I'm not going to go over this in class, but feel free to read through it, and if you have questions, ask about it later. I can go over this on Friday.
Right.
Let me get the book to load. Come on, book. So it is covered on page 205 of the book, why we have to divide by the monthly rate.
Okay.
So take a look at that, and then on Friday we can go over it if you want to, okay?
All right. Thank you.
Yeah. All right, so the other version of the formula is the future value one, so I'm just going to double check future value. And it wants to know what my rate is. So that's my periodic rate, comma, number of periods is going to be the periods per year times the number of years. It wants to know what my payment is, and that was hidden off on this side of the screen. And then what's the present value? I'm starting off with nothing, 0. And oops, what mistake did I make if I'm getting a negative number? Yeah, since that $50 is leaving my pocket each month, that really is, from my pocket's point of view for now, a negative. It'll be positive in the future. So I have to adjust and say I'm paying $50, which is a negative for me. So I have to put a negative payment in from my point of view, and then I get the positive answer, and they rounded it nicely for me too. So if I take this top number and I round it to 2 decimal places, I can see they both match. And I can say make it dollars. All right, let's try another one. So, different perspective. Let's suppose I want to have $10,000 to go on a very nice trip in 5 years. Okay, so I want to plan ahead, save up for this trip. The question is, how much should I put away each month to get that? Now, things I would need to know, I'd have to find a bank that I can deposit money in. And let's say I get a heck of a deal. Somebody's going to give me 3% compounded monthly. Okay. This is pretty similar to the problem we just did. In the other problem, though, I knew the payments I wanted to make, and I wanted to see what the future amount would be. Here, I know what the future amount is supposed to be. I just need to figure out the payment. So what I want to do then is take this formula right here and solve it. Oops, what did I do? Here we go. I want to solve this formula for the payment, D. Now, the trick about this one, which makes it not too bad, D is multiplied by a number, and then D is divided by another number. So the number that's being multiplied, all I have to do is divide that to the other side. And the number that's being divided, I just need to multiply that to the other side. So basically, I'm going to flip this fraction to the other side of the equation. Okay? So I'm just going to show you the other display mode of this thing, and then I'll state what the result is going to be. Let's see. Finance formulas. So I have this formula right here. D is multiplied by this giant parentheses and then divided by this little one. So all I need to do is flip this fraction over to the other side, and I got an answer. So that formula is going to look like this one down here. Okay, so I'm going to write it out, and then we'll use it. Let's see, that looks like the right one. Yep. So here I'm trying to calculate the payment, D. And it's going to be equal to what I want the future value to be after 5 years. So we call that P sub 5. P sub 5 needs to be multiplied by the periodic rate, which is R over K, and then divided by that big parentheses. Inside the big parentheses is another set of parentheses that takes 1 plus R over K to the power nk minus 1. So that's the formula I need. I just need to plug in the right numbers. So my future value is supposed to be $10,000. So there's my 10,000 times 3% compounded monthly divided by big parentheses, second parentheses, 1 plus 0.03 over 12 to the power, and I'm kind of running out of room here. Oops. I better scoot this over. Did I catch everything? Almost. Try again. Oh, come on. We'll move you after. There we go. Might be enough room. All right, to the power, let's see, where am I? 5 times 12. And then minus 1 and close the parentheses. So whip out your calculator, see if you can get a number there. I'm going to do it off to the side of my screen, and hopefully we're going to match. Oops. You want to reproduce that calculation on your calculator. getting about $150 a month. Anyone else get that? If I did it right. And just to double check. Oh, forgot about that. All right, so let's see. I move this guy. Nope. Oh, I can toggle it though. There we go. All right, so it wants the rate. Got that. Then it wants the period. By period here, it means how many installments do you want the final amount in? And we just want one final amount. And then it wants to know how many periods are you going to make payments over? That's 12 times 5. How much money do you have in the bank right now? Nothing, 0. And then what do you want this money to be worth? And I want it to be worth 10,000. I got to type it in as a negative. And so it says 154.69, which matches my other calculation. Okay, so I got it right. Anyone have trouble typing that in? Did you get it that time? Yeah, these are tough. And just how I get this version again up there, I'll just retype it. It's point and click once you type the numbers on the screen. And I highly recommend typing the numbers on the screen rather than typing them directly into the formula, because if you mistype something, it's easier to recorrect it. Or correct it, excuse me. So here I want to take my future value times parentheses, my periodic rate, which is the 3% over 12, and then I just have to be super careful about closing parentheses. I'm going to divide that by a giant parentheses, second parentheses to start the compound interest part, 1 plus rate over periods per year. Close that, raise it to the power, parentheses, because it's a calculation, 12 times 5, which I click on the screen to get. Close it, subtract 1, close the denominator, and then I finally get an answer, which I could tell the computer to format as dollars by clicking on it and then the dollar sign in the toolbar, and it gives me the answer. Okay. So some of you said you like the long crazy formula here better. Totally cool. However, it's good to have another way to do it so you know you're getting the right answer, because the way I enter things are slightly different for each. Okay. So if they match, either I did it right or I'm just totally deluded in both spots, which is unlikely. Okay. If I get it right both ways, chances are I understood what I was doing and it's the right answer. Okay. So we're going to move on to the next kind of problem. Oops, wrong button. There we go. Highlight my answers. Okay, so the next situation we're going to take a look at is what's called a payout annuity. And one cool thing about a payout annuity is a loan works the same way. Okay, so for example, you get a credit card, you go nuts, you buy a lot of stuff. All of a sudden, you owe $1,000. Then you got to start paying it off. If you want to define the fixed monthly payment to pay off $1,000 in a year, what we're about to do would solve that. Other thing a payout annuity is good for, if you hang on a sec. Okay, there we go. If you want to retire someday, it would be nice to have a savings account that you can take regular withdrawals from. And so maybe you figure in the future, I want to have another extra bit of money I'm going to be able to use. I would like to be able to withdraw $1,000 a month out of an account for 15 or 20 years. How much do I need to have in my account so I'll be able to survive that long, $1,000 a month? Okay, so we can answer questions like that with this next formula. So I'll give you the formula and then we'll go over a bunch of different ways to use it. So the payout amount is called P sub 0, capital P. And you can find it by taking the amount you want to withdraw monthly, for example, that would be D, times parentheses 1 minus parentheses 1 plus R over K to the power negative NK. Remember we saw the negative NK in an example in the other class Monday when we were reversing compound interest? Close that parentheses, and then I divide by the periodic rate R over K. So here what we're doing is we're calculating the present value for a bunch of future withdrawals. Okay. The formula on the spreadsheet for this is called PV for present value. And you would need to enter the periodic rate R over K. You would need the number of periods, N times K. Your monthly payment that you're going to withdraw as a negative, and then the last one is 0, which means you want to drain this account completely in the time given, is what the second number is. So those are the two formulas I need to figure out the present value of a bunch of future withdrawals. Okay, so an example of where I might use this. So what amount should I invest now so that I can withdraw $1,000 per month for, I don't know, 10 years. Okay, so I'm putting money in the bank. That means I'm expecting to get some deal from the bank. They're going to give me an interest rate. And so let's suppose they'll give me 5%. Good luck finding that, but oh well. So let's say it's a 5% account that I'll be able to do this in. So this is a situation that would apply here. All right, so let's do the calculation. So the present value of these future payments is denoted P with a 0 underneath it. So that would be equal to the amount I want to withdraw, $1,000, times parentheses, 1 minus parentheses, 1 plus my rate, 5%, 0.05, and I'm making monthly withdrawals, so that'd be divided by 12, raised to the power 12 times 10, and then I have to close this whole thing to match that one. And then I can divide that by the periodic rate in parentheses. Periodic rate would be 5% over 12. All right, give it a shot. See what you come up with for the amount of money we would have to invest today so that every month from now on, we could withdraw $1,000. Oh shit, yes, thank you. The exponent should be negative here. Should be a negative 12 times 10. Thank you, Ian. How do I fix that? Fen, I got a problem. I muted your sound because there was some background noise and I cannot figure out how to unmute it, which means I cannot hear you.
Can you hear me now?
Oh, I can hear you now. Did you mute it too?
I think you muted your side, but I can control on my side.
Okay, good, good. Thank you very much. I can hear you now. Good. Whew. All right, so I'm going to attempt to type this into my spreadsheet. So let's see. This is a payout annuity. It's a big amount. What'd you get? 94,000, almost $100,000. Okay, it's a lot of money. So let's see. So I know what I want my payment to be. That's the $1,000, or withdrawal, excuse me. My APR, 5%, periods per year. That is my 12. And I'm going to do this for, what did I say, 10 years? Years is 10. So I'm going to do the easy formula first. So my present value is going to be equal to the PV formula. And I need my periodic rate, comma, number of periods, comma, payment amount. That's what I'm withdrawing, taking it out, so it's a negative. And then future value is going to be 0, bringing it to 0. So $94,281.35. Okay. So I'm going to type the other version of the formula just because it's fun. All right. So 1,000 times parentheses 1 minus parentheses 1 plus R over K to the power. And here's where I often screw up. Like Ian pointed out, I forget that darn negative, and then it all goes to hell. So my parentheses have to be, a power has to be a negative 12 times 10 or 10 times 12, whichever you like. Close that, close the numerator, and then I can divide by the periodic rate, which is 5 over 12. And then I should get the same number, but not rounded. Yes, nice. Wow, that's intense. It's like biking up a steep hill. Yeah, there's lots of annuity calculators out there on the internet where you just say, I'm doing annuity, and it says, okay, what are the things you want to know? And it whips it out. You have one there? Cool. You should post it to the forum for this class. Yeah. Negative D, otherwise you get a minus, which kind of like, oh, it throws you off. Yeah. So either way, there's complications no matter what. It's challenging. Okay. So all of these, now keep in mind, all of these programs, formulas, there we go, can be used in multiple directions, which is kind of cool. So I can say, okay, how much do I need now so I can get this payout every month, right? Other thing I could say is, well, suppose I need $10,000 now. How much would I have to pay each month for that? Well, that's the same situation in reverse. Where would you apply a situation like that? Well, if you wanted to buy a new car and that car costs $10,000, or let's say, oh, that's even better. Let's suppose you wanted to buy a new house, right? And you got a hell of a deal on that house. Somebody's willing to sell you the house for $94,281.35. $94,281.35. Okay, it's a hell of a deal for a house. It's got 2 baths, it's got 4 bedrooms, it's got a furnished basement. Well, the wiring's all knob and tube, and it could explode into fire at any moment, and the basement's being held up by sticks and rocks instead of a real foundation. So it needs some work, right? So guess how much. And then you go to the bank and you say, hey, bank, I need $94,281.35 right now. And they said, okay, how long do you want to borrow this money for? And you say, I don't know, how about 10 years? And they say, hey, we got a great deal at 5%. Guess what your monthly payment would be? $1,000. Yeah, that's the reverse of this problem right here. Yeah, it turns out a payout annuity and a loan are exactly the same thing, mathematically speaking. 2 different scenarios, same formula. Yeah. So if you check this problem out on the board here, there's my $94,281.35. For 10 years at 5%, you would have to pay the bank $1,000 a month, right? Okay. So I'm going to analyze that in reverse, and then we'll check it out in a different way just to make sure. I just make a new post in the finance forum, question forum. Okay, so here's what we're going to do here. We're going to have monthly payments, right? We have to pay some money in. Payment. The bank charges us interest, right? Agreed? No, charge me interest. But when I pay the bank money, I get to reduce my balance, right? So I get what's called a balance reduction. And then I get to check out what is my balance. Okay. And how much am I borrowing again? Anybody remember? Exactly, that much right there. Okay, so I'm going to borrow that much. So we're going to build a spreadsheet that will analyze what's going to happen here. Now, the bank claims that I have to make a payment of how much? $1,000. So I'm just going to type 1,000 here and see what happens. Other information that's relevant, I have an APR, right? My APR was what, 5%? And I have a number of years to pay this off. What was the number of years we're picking? 10 years. Okay. So let's do it. All right. So help me figure this out. So let's see. 1 month goes by, right? This money has been sitting in my account. I owe the bank that much money. They're going to charge me interest, right? Okay, simple interest is take what you owe, multiply by the interest rate, and then multiply by how much time has elapsed. How much time has gone by? 1 month. So 1 month is 1/12 of a year. So after the first month, I owe the bank $392.84 in interest on top of the $94,281.35. So the bank gets my check for $1,000. The first thing they do is say, thank you for that $392.84 in interest. That leaves you 1,000 minus that to pay off your debt. So now my debt gets reduced by only $607.16. This is what happens at the bank. Then the bank says, okay, let's take that off your balance. So they take your balance, they subtract what's left of your $1,000. You still owe us $92,674.19. What's going to happen next month? So the same thing's going to happen next month with slightly different numbers. How much am I paying them in the second month? I'm still paying them $1,000. Aren't they going to calculate the interest the same way? Yeah, so I'll just type it in just to make sure. They're going to go, okay, what's your balance? Multiply it by your rate. And instead of multiplying by 1/12, I'm going to divide by 12 if that's okay. Hey, I owe slightly less interest, like $2.50 less, because I paid some of the money off. Okay, and they're still going to do my subtraction here. They're going to go, okay, you gave us 1,000, but you owe us this much interest. That leaves you $609.69 to reduce your balance. And they just do this month after month after month. Okay, Now, aren't these calculations totally repetitive? Okay, so can't the spreadsheet just copy those formulas down for me each time? Okay, the only catch is when I do this formula right here, I have to fix the 2 because row 2 is where the interest rate is. So I got to flag that with a $sign. Otherwise, it'll work just fine. So what I'm going to do is I'm going to fill my payments down for, let's see, how many years? 10? 120 months? Getting there. Oh, too far. 2 extra months. All right, 120 months. And if I did these formulas, if I did these formulas right, I should just be able to fill them down. So this is the one with the $sign. So I'm going to grab that row and I'm going to fill it down for 119 months. And guess what? My balance should be at the end. Should be 0. Perfectly. Whoa. Isn't that magical? You don't think that's magical? What the hell is wrong with you?
She's like, no.
This is totally magical.
Hey, I already told you why it's not magical, okay? I'm having all that.
Grasping all of that?
I got it. It just sucks.
I'm sorry, you think it sucks. I think it's magical. So I started with $94,281.35. Now, usually home prices aren't that weird. There's something like, 150,000 and we usually haggle in thousands for a home price. They don't go down to the nearest cent usually. However, when you do buy a house, there's all these added costs at the end. And so the house price does go up by some weird amounts. Okay? So that could be the final price of a house. So I'm going to look at this in reverse now. So we're going to reverse the formula we just did, and then I'll show you the spreadsheet version of it. And then I'm going to let you go to the lab and screw around with these kinds of things. So new page. So the reverse formula is where we're given something like, I want to borrow $150,000 for this house, or I want to borrow $30,000 for this car. And then we have to calculate the monthly payment. So all we have to do is reverse the formula I just gave you. Right? So look at the formula I just gave you, that whole D times 1 minus blah, 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 blah. So reversing it, we are solving for D. This is usually called an amortization payment, by the way. Amortization payment. And the table I just made is called an amortization table. Payment. So to calculate an amortization payment, you need to know what the initial principal is. That's the P sub 0. And then we multiply that by the periodic rate, R over K. And then we divide it by this long crazy thing, which I like to put in parentheses. 1 minus parentheses 1 plus R over K. Ian, what do you think the power is going to be? Yeah, negative NK. And that's it. Close it. That's the formula right there. On a spreadsheet to calculate, what's that? Ah, no. It turns out in this case, let's go back one more. I have to take, I need a highlighter. I'm trying to solve this for D, which means this guy needs to be divided to the other side. So it still stays negative because it's switching sides. Yeah. Could we rework this whole thing with a positive power? Yes, but it's way messier. Okay, so sometimes it's not worth going for positive powers. All right. So the spreadsheet version of this is called PPMT. It's got 2 P's, not to be confused with a pay. I have no idea. I don't know. Because there is another formula that's called PMT, but that does a different thing. Oh, am I lying here? Wait. Oh, shit, I'm lying. This one is PMT. The other one is PPMT. Okay, so I lied. Sorry. Hate when I do that. So if you want to figure out a payment on a payout annuity, it's PMT. If you want the payment on a savings annuity, it's a PPMT. So notice that cheat sheet I gave you the other day, right here. Oh, that's not it, right there, yeah. Savings annuity payment is a PPMT. I did not mistype that. It's 2 P's. A payout annuity reversed is just a PMT on a spreadsheet. Okay, don't mix those two up. Otherwise, you do not get the right answers. You enter almost the same stuff in a different order. Let's see, where's my notes? Here we go. All right. So what the PMT formula wants is your periodic rate. Oops. Periodic rate. That would be R over K. And then they want the number of periods. That would be N times K. And then it wants what is the loan balance, and that has to be entered as a negative because you owe it. And that's what we're calling P with a subscript 0. And let's see. Other fields, I think the other fields are optional. So I'm pretty sure we can just close that. I'm going to double check that right now in my spreadsheet. So I'm going to double check that if I borrow $94,000 at 5% for 10 years, that the payment should indeed be $1,000. And so my belief is I should type equals PMT, and the rate is going to be equal to, oops, 5% divided by 12, right, because it's monthly payments, 10 years times 12, and I'm typing 12 because I don't have it anywhere else on the sheet. Present value is the negative of what I owe, and then I should be able to close the parentheses. The other two things are optional. Yep, I have to pay $1,000 a month to pay that off. Okay, so just some other things to double check. How much interest am I paying on this? Well, if I add the interest column up, that would be all of these numbers here. Oh, well, we got a few extra. I'm going to pay $25,718.65 in interest alone. Okay, in interest alone. Now that's only 10 years. Usually loans for a house are longer, 15, 20, 30 years. Okay. Do you think I'd pay a lot more interest over 30 years? I would pay a lot more interest over 30 years. Yeah, I would. All right, that's a lot for today. We're going to stop here. And if you're not done with your homework, then you should get into the lab and start trying to do homework problems, either on a spreadsheet or with your fancy calculator. And then we will do some more of these problems on Friday and possibly go over the origins of these formulas in more detail. I know Fen's curious about that. It's pretty cool, but it's kind of tedious. But the algebra is pretty amazing. I can't believe you're just not in awe over this spreadsheet.
I lived all over it, but I suck at,
How many times have you made a spreadsheet like this? Once? Twice?
No.
You've made 100 of them? So just keep this in mind. I've made spreadsheets like this hundreds of times. So I make it look easy. You're just learning to make them, so they're a pain in the butt. That's just life. It's the way it goes. What's up? Soon. Today or tomorrow. Yeah. Yeah, it's on my list of things to get graded ASAP. All right, Fen, do you have any questions for me?
Yeah, I'll upload the written assignment. Did I upload it right? Not sure.
Okay, let me take a peek.